This video is a continuation of the exceptions notebook, and it's going to discuss user-defined exceptions.
So Python has a number of built-in exception objects covering many common types of issues, but this set cannot cover all possible situations or problems. So we can actually create our own exceptions, and we haven't discussed classes or inheritance yet. And so this subsection is included here more for completeness and future reference, and also to serve as a sort of sneak peek for things to come. Let's start off with a few guidelines, though, for defining your exception classes, and then I'm going to briefly walk through the code in the example here. When building a custom exception class, we usually keep the class very small, meaning that we don't include large amounts of data or functionality. For instance, it's usually expected that the data stored in an exception is nothing more than a message. However, it may contain anything you like, but keeping these objects as simple as possible is highly recommended. Also, when you create a module or package that contains several distinct exceptions, it's recommended that you create a base class for your exceptions, from which you will derive all of your other exception classes. Also, all exception classes should derive directly or indirectly from the exception class provided by Python. And I've given you a link here to the exception class in the documentation, as well as a link to the built-in exceptions that are available to you. Now, the last guideline I have for you is that it's common practice to give exceptions names that end with error, like name error, value error, zero division error, and so forth. This makes these objects more easily identified as exception objects. Okay, so before moving on to the example code, I've used terms like class, and base class, or derived class, and these concepts are going to be covered in detail in the notebook on classes. However, briefly, a class allows us to define new types of objects containing any data and functionality that we require. Inheritance basically allows for one class to inherit attributes and methods from one or more other classes. Now, again, we're going to cover this in much more detail in the notebook on classes, but for now, let's just start with this sort of primitive definitions and look at this example. The first class here is named example base error. In the parentheses, we see here the class exception, which is provided to us by Python and is the base class for all exceptions. This notation, class example base error, and then in parentheses, tells us that we're defining a class named example base error, and that it inherits from or derives from class exception. And this means that it's going to inherit all the attributes and methods that the exception class contains. Now, one other guideline that I haven't mentioned is that if you have several exceptions in a module that you're creating, it's recommended that you have your own base class for each of these to derive from. So in our example here, example base error will actually serve as our base class for our exceptions in this notebook. Now, for the body of our class, I'm providing a docstring, which is going to be used by the help system. And then we're using the pass statement, meaning this is an empty class. It's not providing any additional data or functionality. The next two classes, input error and transition error, are going to be our new exception classes. Note that these inherit from example base error that we just defined here. And in both of these classes, we're defining a special function, init. Now, this function and the reason it's special will be discussed in the class's notebook, but basically it's going to allow us to specify two new attributes for this exception, namely an expression and message for the input error. And then for the transition error, we're going to use it to specify previous, next, and message. These attributes are our custom attributes that we're adding to these new exceptions. And the init function is allowing us to provide values for these attributes when we create an instance of these exception classes. That is, when we raise one of these exceptions. In fact, if we look at the bottom of the block here, we have a try statement where the try clause simply raises an input error exception. Notice that input error is one of our new classes. And notice on the argument list here, we're passing two strings. One, a plus b, which is going to be for our expression, and another string, which is going to be the value for our message attribute. And after our input error exception is raised, you see in our except clause, we're handling input error as IE. So we're giving it the variable name IE. And in this clause, we're simply going to print out IE.expression and IE.message. These are the two new attributes that we've added here inside the init function. And we can access them using the dot notation. Now, because our input error inherits from example base error, which inherits from Python's exception class, we can still use ie.args. Okay, so we obviously left out a lot here concerning classes and inheritance, and we went through this example kind of quickly, but we're going to discuss all those topics in detail once we get to the classes notebook. However, at this point, you should hopefully be able to include the built-in exceptions in your code and start to handle errors during execution.